Hello students, in this experiment we will be studying power transfer theorem. For this we need to consider power supply, and power supply is an electrical device that supplies electric power to an electric load. For any power source there are two parameters, Vs and Rs. Vs is the source voltage and Rs is the source resistance. Basically here we will study how Vs and Rs are varying with different parameters of the circuit. So these are the objectives of the experiment, and this is the circuit that we are going to follow throughout this experiment. According to Thevenin theorem, we can convert this circuit into an equivalent circuit as shown here. The values of Rs can be calculated from these circuits using the formulas given here. And these are the apparatus required for our experiment. This is the DC power supply. Using this, we can set the value of V0 to 20 volt. This is the network board. It consists of voltmeter, ammeter, and different resistances. This zoomed image shows the values of all resistors, and also, as you can see, it depicts how they are connected internally. This is the back view of the network board. This is the rheostat, which contains different resistances. The values of resistors are mentioned, that is this 5000, 2000, 1000. When all keys are connected, it means resistance is 0. Suppose we want to set RL is equals to 500, then we need to take out the key corresponding to this 500 ohm, and this is the infinity key. Whenever you have to change RL, first remove this infinity key and then take out the key of required resistance and reconnect the infinity key.
So now let's start the experiment, that is study of power source. So this is the board for this experiment. These are the resistances of different values, like these are of 10 ohms, 100 ohms and 1000, 2000, and these are of like 500. So these all are connected in series, as you can see. All these are connected in series. This is the ammeter and this is the voltmeter. So now let's start with the connections. We will follow this circuit throughout the experiment. This is the voltage supplied by a power source, that is V0. So first we will connect the positive terminal of this power source to R1 and R2, and then this common terminal of R1 and R2 is connected to ammeter and then voltmeter. After that we will connect this load resistance across A and B, and then we will vary this load resistance in intervals of 100 to 100, and we will note down the corresponding values of voltage and current, and then by these values we will calculate RS, PL and PS. So RS is equals to Vs minus VL by I. So this is the experimental value of RS, and for the theoretical value we will calculate from this formula. So here we are taking R1 is equals to 500 ohm and R2 is equals to 1000 ohm, so that the ratio remains 1 by 2. So when we will calculate this theoretical value of source resistance, so we get this value 333.33 ohm. So now we will vary this value of RL in intervals of 100, like 100, 200, 300, but we have to include this value of RS. So now we are like minimizing our interval so that these values close to these values will be obtained in this table. So now 330, 360, 390. So first of all we will connect the positive terminal of power source to R. So this is the power supply, and these two knobs are coarse and fine. When like I will switch on this. So these are the two knobs, this is the coarse and this is fine. When we want to change the value by significant amount, we will use this coarse knob, and then to fine tune this value we will use this fine knob. So we have to set this value to 20 volt. So now we will connect. So this positive terminal of V0 is connected to R1, and here we are taking R1 is equals to 500 ohm, that is this second one resistance. So this is 500 ohm, and then this R1 is connected to R2, and R2 is 1000, so we are taking this. Now this R2 is connected to negative terminal of the voltmeter. Now we will connect the common terminal of R1, R2 to ammeter. So this is the R1 and R2 common terminal. So this is connected to ammeter, and now this ammeter is connected to voltmeter. So ammeter to voltmeter, and then this voltmeter is connected to R2 and V0 common terminal. So this is the common terminal of R2 and V0. So from here we are connecting this. Now we will switch on these circuits. So it is negative, it is due to the polarity. You get this 13.3. So Vs is equals to 13.3 volt. So now we will connect this RL and vary this according to these values, as I have already written this, and we will take these values. Now we will connect the load resistance from this voltmeter, ammeter and voltmeter common terminal, and voltmeter. So this is the common terminal of ammeter and voltmeter. And these are the resistances, like these are mentioned here, that is 100 ohm, and these are of 10 ohm. So first of all we have to connect 100 ohm, and these are connected in series. As you can see, these all are connected in series. So like first I am connecting this common terminal of voltmeter and ammeter to this, and then if I have to take 100 ohm, I will connect here, and if 200, then here 300, because these all are connected in series. Okay, so this we are taking 100 ohm, so we will connect this RL second terminal to here, like R2 at V's common terminal. So this is the common terminal of R2, sorry, so R2 and V2. So we will connect this to here. So this is the 100 ohm. Vs is equals to 3.1 and the corresponding current is 13.9. So we will note this down. So for load resistance is equals to 100 ohm, our VL is 3.1 and I is equals to 13.9. Now we can calculate the value of RS by this formula. RS is equals to Vs, that is 13.3, minus VL, that is 3.1 upon 30.9.
These are the important points you need to consider while performing the experiment. The smallest division, that is least count of voltmeter and ammeter connected in the network board, are 0.1 volt and 0.1 milliampere respectively. Take minimum 15 readings for each table. Check wires before starting the experiment and switch on power supply after connecting the circuit. Make sure that the keys are properly tightened in rheostat, and whenever you have to change RL, first remove the infinity key and then take out the key of required resistance and reconnect the infinity key. Thank you.